Hey, it's Gabe here from the Hive. I'm here to show you our infrared light detector prototype. The functionality of this prototype is to detect changes in infrared light between the light emitter and the light detector. When something is placed in between the light emitter and the light detector, the value skyrockets to about 1,000. When you remove that item or whatever is blocking the infrared light, the value falls back down to approximately 27, 28. The materials used for this prototype are resistors, the light emitter, the light detector, and the Arduino board. The manufacturing process that we use was we began by gathering all the materials, researched online similar prototypes and whatnot, and then wired it based on the tutorials online and using help from professors. The light detector will be placed on the exit of the hive so that when only a few bees pass through, it'll break up the infrared signal, increasing the value, but only for a moment in time. But when the hive is swarming, many bees will be passing through the exit, so the signal will be broken up for an extended period of time, and we could use that to send a signal to Andre or the beekeeper. Now I've got our sound detecting prototype for you. The key function of this prototype is to detect changes in sound and volume that indicate swarming. You can see that when it's silent, the microphone stays around in the 350 range. And when Mike offers a noise to the microphone, the value rises. The materials for this prototype include the Adafruit microphone, the Arduino, and wires, as well as a power source, which will be the laptop for the prototype. The manufacturing process of this device is to start with 3.3 volts going into the Adafruit microphone, which then sends a signal to the Arduino recording the data. This device works by being placed near the exit of the hive. When the hive is about to swarm, the values taken by the microphone will rise for an extended period of time. This then signals the Arduino to send a message to Andre or the beekeeper interested that the hive is about to swarm. Because we are not certain which sensor will detect swarming the best, we will continue to work with both types of sensors, gathering test data on each until we reach a final decision.
The sound device is that it can potentially track multiple beehives at the same time. It can also be installed easily on the top of the beehive. The cons of the sound device is that it can get interference from other source noises, and it also is difficult to test without actual bees swarming. Now, the light sensor has different pros and cons. The pros for it is that it could be more accurate and it could be used to track day-to-day hive activity. The cons are that one full setup per beehive increases the total price, and also that we can't see the infrared light sensor, so we wouldn't know when to change the battery or not.